Hi everyone, welcome to the 49th webinar in 12D's training webinar series. My name is Lisa Stewart and I'm the Marketing and Communications Coordinator at 12D Solutions. 12D's training webinars showcase common industry challenges, taking a close look at industry best practices and how these can be implemented using 12D products. The aim of these webinars is to upskill 12D users and broaden their understanding of the capabilities of 12D products. We run these webinars regularly and record them for posting through our website and on YouTube. The first 48 webinars from this training series, as well as the 44 webinars from our Industry Solutions series, are available on our YouTube channels if you missed those. During this live presentation, you'll be able to type your questions along the way, as shown on the screen, and we'll answer as many as possible throughout the webinar. At the end, I'll read out some of the questions to the presenter if there's time. Today's webinar, Kerb Return and Cul-de-sac Design, will be presented by Matt Stevens of 12D Victoria. Matt takes care of 12D sales, support and training throughout Victoria and Tasmania. In today's webinar, you'll learn how to create basic Kerb returns and cul-de-sacs by using the Kret Convert to Computator command within 12D model. We will also go through some first principles with a super alignment to see what this tool actually does for the designer, so it can be modified to cater for more complex cases. Over to you, Matt.
Thanks very much, Lisa. Yes, as Lisa said, this is a webinar on Kerb return and cul-de-sac design. So basically I've just produced a project at the beginning where a lot of you will know it from the training we do, and I'm just going to explain how we do the Kerb returns on this road RS2D01. I've done some previous work in this project. I've just graded this road around here, and I've graded this road around here. So if I take a look at the design view, that's what I've got, and I've put some Apply MTF functions along each road. So this road here, RS2B01, is 4.2 meters to the lip, and this minor road RS2D01 is 2.7 meters to the lip. Okay, the first thing we need to do with Kerb returns is you can create a Kerb return using a super alignment by two means. You can either use a macro we have in our command system, or you can create it from scratch yourself. Let's go through both ways. I'll show you the easier way and the one for more simpler applications. So you can actually go to Design, Roads, More, and in here there's a Kret Convert to Computators option, so it brings you up that. Or if you've got the road toolbar on display, you can also gather the Kerb return function from that one. So if you haven't got the road tool on display, toolbar, view, toolbars, and you just go down to where it says road and just turn that on, and I've just got mine placed here for the moment, and on that particular button or that particular toolbar is that button there which launches the same thing. Okay, so what I'm going to do now is I'm just going to shift on to my alignment view with just the alignments and design on my alignments. I'm going to firstly design this with the left hand. It says pick all strings with left hand orientation, so basically that means that all the Kerb returns you can just hang a left hand template off them. If you're doing central medians, that will become the where you'd hang a right hand template off them. So let's have a go at using this. It's probably the easiest method. So in this case, I know this road here is the approach road because I'm going to create it from or in an anti-clockwise direction. So I'm going to make this 4.2 meters. Sign is not important in this one, and we're going to the departure road that is 2.7 meters. Okay, now this road here, it actually, if you've done the training with us, it's one-way crossfall, and the high side's on this side. So it's actually the approach that's positive 3% crossfall, and the departure, this road's just a simple crowned road, the road heading up that way. So if I then go and select my radius, or it just puts in a simple fillet of 12 meters, and then select off my approach with direction. So I'm holding left button down and sliding up chainage, and the departure likewise left button down, slide, release left button, accept, and then now I've managed to pick the departure string. So in this particular webinar, I'm not going to create the apply many or the apply MTF automatically. What I'm going to do is just switch that off, and I'm going to choose a label style from the 12D label styles. We have one in there called Kerb's left hand side. I'm going to make use of that. I'm going to give this a name, RSK D01. This is my first Kerb return. I'm going to stick it into a model alignment Kerbs, and I'll just make it a simple green color. I don't need to fill out the template, the seed MTF or the tin because I haven't got the create apply many button switched on. So let's go ahead now and give that a process. So it's now processed it, and it's put a Kerb return in. So it's looking pretty good for us at the moment. Okay, but what's it actually done? Let's have a look. If I then take a look at the longitudinal section of it, it grades it in the longitudinal direction as well. So what it's done is it simply, we've told it here, offset 4.2 meters, and then at positive 3% crossfall, so that's how it gets its height. And then on the departure, 2.7 meters across to here, and minus 3% crossfall. So it takes the level there and comes across at minus 3% crossfall and gives us a level at the end. And then it produces just reverse curves in there, so it in the middle of our Kerb return, so the levels work at any time. If you want to change that later on, you can. Let's take a look at what it's done. So I'll just pop that down there. If I do a string editor using my super alignment minibar here, and I can either pick the string in section or the plan view. So I'm looking at this string here, being a super alignment and being element method. I'm going to click on this button here. Firstly, I'm going to start off looking at the horizontal. So the horizontal area here it's used is a fixed compound Kerb. So it's set up the fact that it's using an FX string and an FX string. So this thing here with that little yellow dot there is a commutator. So basically it's producing up here a fillet, it's a commutator, and it's going from string to string with a radius of minus 12. See how that macro below, or that 12D command, automatically selected the minus 12 for us. So if you were to do it from scratch, you would have to know what sign it is. So anti-clockwise is a minus value, and a positive arc direction will give you a clockwise arc. So it's also put in the strings. Okay, so that's the first string, the FX string. So it gives you a bit of an idea about where that string is. And that one there is the string in the opposite direction up the RS2 DO1 road. Okay, and it makes it very easy now to change some of these things. You can now go into the fixed compound. If I wanted a different radius, say 15 meter radius, set, and it's out to a 15 meter radius. And what the beauty of this is the vertical will have changed as well. So let's have a look at what it's done in the vertical here. So in the vertical, we've got a couple of different components of the vertical, or elements of the vertical, that are not visible. Let's go switch them on. So if I turn on that and make that visible, and if I turn on this end and make it visible, what that does is it basically looks at the grade of the center line of the road at both ends, and it marks down the center line of the road so that you can be assured that at the beginning and at the end of your Kerb return, you don't have a massive change of grade there. Normally, you know, up to 0.5%, 1%, sometimes okay. to change grade at the beginning of a curb return, but this one here automatically links it in and shows you the actual incoming grade, the outgoing grade, and also the two reverse curbs in the center. So I'm just going to switch them back off and make them invisible again. So sometimes if you want to produce long sections of your lip profiles, you can actually turn them on, and then in your lip profile you'll see that you'll have these 10 meter, in this case, relative start and relative ends on your string. Okay, so that's the curb return on that side of the intersection. Let's put one in from scratch. So I'm just gonna, let's quit out of that one, so it should go back to a 12. Okay, let's do it from scratch, and I'll do it from the other side of the intersection. So if I do a create, and I just go same as, and grab the curb return there, better change the name. And then basically come down here, just check that the labeling's right. Yep, that looks right to me. Yep, that looks fine. We should be able to run with that now. So I'll hit create. Okay, so now I've got the super alignment curbs RSKDO2 set up. So we're doing it by element method. So curb returns make a lot of sense to do by element method. As you see, they're very easy to change. And if you use IP method, you might have to change like IPs at the end of your strings once you change them. So element method is super for this. So in the horizontal, I'm just going to do an insert. And what I'm going to do is insert a commutator, so I tie it to the two road strings. So it's an actual fixed compound commutator. So I'll set that. Go to the fixed compound. As you saw before, it's a fillet, and we can use fx string and fx string. Okay, nominator radius. So in this case, with the left hand rule, I want the zero chainage to be up here and the high chainage to be down here. So the radius again becomes a negative. So if I make that minus 12, okay, and do a set, and go to the fx string here, and select the first string, which is this string in this direction, so in the negative direction. I give it an offset, so how wide is that smaller road, which is minus 2.7, as I said before. I'll set that, go into this one, string this way, because we're making it go up around here. See, automatically it puts the curb return in. All I need to do is adjust the offset, and the offset in this case on the major road is minus 4.2. So very easy to do in the horizontal. Okay, let's now take a look at it in the vertical. Okay, so I'll give myself a new one in the vertical here. And if I give myself a new shot here, okay, what I'll do is I'll do a commutator, and I'll do a fixed line commutator to pick up that initial grade. And the fixed line commutator I want to use in this one is what we call a chainage reference commutator. And the reference string I want to draw from is this reference string here, because this is how I want to get the end level of that. Okay, so what I want to do in here is chainage type at vertex. The vertex index is the first vertex. That's where I want all this to happen from, the first vertex of my super alignment. The slope type I'm after is a typed slope, because I know it's minus 3% crossfall. And the relative start minus 10, and the relative end I'll put as 0. So if I push this one down, set, and do a look at that, it's actually created an incoming grade of minus that's 10 meters long, just to give me an indication of what the grade is along the super alignment at that particular point. Okay, next thing I would do would be to throw in the reverse curves. So insert now, throw in some reverse curves. So you'd put in parabola free, put in asymmetric compound curves, and then 50% on the leading curve, 50% on the trailing curve. We'll hit set. Now this here gives an error because with the free compound parabola, as I've got, it needs something on the other end to connect to. So again, I'll do an insert, and I'll do a commutator, fixed line commutator, as we did before. We'll do the type as being a chainage reference again. The reference string this time is off that string, and the chainage type we're after is again at vertex, and the vertex index this time is 2, and the slope type is going to be a typed slope, and the slope, if you remember from last time, positive 3%, and I'm now going to put this at 0 and 10. So what that's generated for me is it's generated vertical along that particular design. Okay, so normally what I would do too, I'd go and make that first one invisible, and the second one turn off its visibility as well, and I'd then go and finish that one off. Got a bit of a save there as well, and then okay, now we've got the two Kerb returns set up. I would then incorporate that into my design. Okay, so the way I would do that is, firstly I would want to run a Kerb return templates off both those. So if I look at the templates, I've actually got one in here called Kerb left hand side, and that's the Kerb left hand side template. It just starts from the lip of Kerb, moves across until it gets to the ELL, which is like the edge of verge line. So the next step in the process is to apply a template around each of our Kerb returns here, and the easiest way to do that is to use the Apply MTF manager. So design, apply MTF manager. Now with the Apply MTF manager, if I just select the model alignment Kerbs, you'll see it populates in here, and it's actually got the tin to interface. How does it get the tin to interface? That's because previously it reads from the Apply MTF defaults, and I've set up the Apply MTF defaults as the tin survey, as being the tin I more than likely want to interface to. If I look at the Models tab, I've just gone and changed the color of my sections there. And I'll look at the tin tab. We're going to create a tin called just a road tin there automatically, and it's going to be a Visroad asphalt default color. And I forgot to say, under the miscellaneous, I'm mapping the actual templates, because the templates are in the Vis colors, so I'm mapping them to colors I can see on my plan view. So let's go ahead now, and we'll say for these two Kerb returns, I just basically click at the top of template left hand side, browse, and I select the Kerb left hand side. The view that I want to see the details on is a design view, and I'm going to create a chain, and I might call that chain Kerbs. And okay, under here everything else looks right. I want to create the road tin as well. Okay, let's get this up and running. So hit create and update, and away it goes, and it creates these Apply MTFs for me. I'm done with that now. So if I look at my design view, what's it done? It's actually created my Kerb returns for me. So what I'm going to do next is I'm just going to take a look at, we'll go through to the MTFs and just tidying them up a little bit. So edit data. So I'll take a look at this major road, the RS2B01, and I'll flick back to the align view, and the modify, just go into my modifiers here, and I basically just want to trim out the strings in this, okay, where the design strings, I just want to trim from the lip of curb back for the length in between the two curb returns. So if I jump back into the alignment, I'll give myself another line at the end of this. Let me just pull this down a bit. Of course, I give myself a region. Call this region intersection RS2D01. So for another line, use the remove function. So fixed, remove from name. It's a good option to use. The name, it's on the left hand side, so I'm removing from KLL because that's what my lip of curb's called. And the start chainage I'm after is the lowest drop chainage of other string to the highest drop chainage of other string. And the two strings are, so the lowest drop chainage, so we're talking about the chainage on our design line here, and the lowest drop chainage will be the lowest drop chainage of this, so it'll just keep dropping chainages onto the main design line, and it'll pick up the lowest drop chainage of being there. So I just nominate that string. So it doesn't matter, doesn't have to be the direction. And on the other side, it's going to be the highest drop chainage of this one here. So if I pick that and hit apply, it does the automatic apply for me. You can see the little arrows showing that it's in the right spot. So if I now take a look at my design view, basically now all I've got is a lip of curb that runs through that area there. So all is good. So we'll save and finish that one. Now what I want to do is the road going up this way. So let's edit data off my recalc view, and let's do it on both the left and the right hand side. So in this one, these are just running presently from the start of the reference string to the end of the reference string. There's one putting in a template, and there's another one in there putting in modifying the link, so it's narrowing the road. Rather than being 4.2 meters in the template, it's now back to 2.7 meters. So what I'm going to do here is I'm just going to flick back to my alignment view, and I'm going to say this working on the left hand side here. So we're going to run this from the start reference string, or change that to the lowest drop chainage, or sorry, the highest drop chainage of this string, this curb return string. That's where we want to start it. And I could be lazy and I could use Control C now and paste this one in here as well, just so I don't just so I don't get errors. It's good practice to set those both up. So if I now hit apply and come back to the design view, you see now these ones take off from that direction. Okay, now I'll do the other one on the other side exactly the same way. So modify right, flick over to my alignment view. My start chainage would be the highest drop chainage of other string again. Pick this string, it's the highest drop chainage because we're talking about dropping on this string now. OK, Control C, Control V. There are a number of ways you could set aliases to do that as well, and apply. And if I flick back to my design, now I've got that looking pretty good, okay, on both sides. Okay, but this area here I've got nothing inside it. So let me, it's created tins in those locations. Let me just create a super tin. So create a super tin, and I'll put the two roads into it. We'll call it super design. Put the two roads into it and the survey, and then we'll see what that gives us. So survey down first. So these take in precedent order. Then I'll put down RS2B01, one of the roads. The second road, RS2D01. Then I'll come back and put the two curb returns in. And I'll just hit create. Okay, so now if I went to a 3D view, and turned on the model tin super design, what you'd see is what we've previously done. But because we've done nothing on the right hand side of our curbs, we're not getting that area filled in there. It's just defaulting back to the survey. So a quick way to fill that in is to use a snippet in 12D. So I'll get out of that particular road. So you use a snippet and you fill out the right hand side of each curb. So if I then look at the alignment view again, back to the design, to an edit data, select this one here. Let me just make that on that half. Let me just always make sure I have the auto recalculate on, modify right, and I'm just going to use a snippet. And this snippet can be found under the library. It's the second one in the list. So I normally copy my snippets to my project, so I'm going to do that, use the one I've got in my project. And in this one, all I need to do is nominate an approach string, because all I want to do to get an estimate of this area in here is just extend my cross sections across to the lipper curb string here, and then to my center string in this location here after the intersection. So I'll do that as well. So I'll go, the approach string is this one here, my departure string is this center line that runs up there. Now if I hit apply, see now you get the cross sections that go across to the center of the road, hence this area, this threshold of the intersection gets filled up. So that's for that one. Let's do it on the other side now. So edit data, pick any one of the sections on there, do a modify right, type, fixed, insert, fixed, what are we doing? Sorry, inserting a snippet, and then we're inserting that snippet there. And this time, because it's running in the other direction, we want to pick up the design line, because we want these from the start, we want it to match the design line or the center line of this road, and then the second departure string is the lipper curb on this side. So always make sure you tick auto recalc, and then I go down here, pick that with direction and the departure string as well, apply, and away she goes, and now our threshold is done. And I can save and finish that one off. If I do a redraw of this view, now I've got my intersection ready. Let's go save the project there. So with that now, we've put in two simple fillets. I've shown you how to do curb returns on the two simple fillets. If I go back to align and just turn on for you the tin super design, you'll see there it grades pretty well with what we've done. It's got that little threshold bit works pretty well to give a decent grading through the intersection. So you can see that's one-way crossfall across this road here, and you can see it's a crowned road that we're entering going through this way. Okay. Now we just did that for simple fillets. What about if this lipper curb here wasn't even a fillet? What about if it was like a 3-center curve or something like that? So all I would do for that, I'll just turn off the align, okay, turn off the tin design rather, and then I'll just go in there and I'll edit this string here, okay, and to modify this string, so if the road gets wider or narrower, you just got to go into your parts, okay, and look at the horizontal, and the horizontal parts of this, it basically is telling me it's a fillet. There was the radius, there were the two offsets that we were using. Okay, in this case I mentioned maybe we could do a 3-center curve. So to do a 3-center curve on this, rather than fillet, you just drop down to a 3-center curve. So if you've got like a truck to get around the corner and you've got a turning template on this corner and you want a 3-center curve, very easy. We just do a fixed string departure. I'm just going to type in some values in here. The approach radius, -15. Normally the offset -1, so the middle radius -10, departure radius is 30, and the departure offset again is -1. So if I go and hit set on that, nothing happens. You lose all the information off that particular Kerb return. That's because it's lost the link to the two FX strings. So I need to go and put those two FX strings back in. So pick that one there, and it was an offset of -4.2. Set that up. And this one here, I'll do a pick it in that direction, and that one was an offset of -2.7. So with that information, it should now be able to solve that particular Kerb return. Now I've just realized that I messed up this intermediate radius. -10, this -30. Set that. That should work okay. Yeah, and if I look at the profile of it, because I'm only profiling, if I go down to the vertical here and take a look at the vertical, the third line on the vertical here is actually looking at vertex index 3. That's where it's ending up. So it's actually, vertex index 2. So it's actually ending up at that vertex there. So you can see that. So I need to just extend that because we've now got vertex 2, 3, and 4. So if I go and change that vertex to 4, I should get, as you can see, I'm now getting heights along the whole length of that string. Okay, so I'll just set that. So really what I should do is finish off that, and I really should have a chain. So I'll just quickly create a chain. So chains create that runs this whole thing, and I'll just call it design chain, and we'll write it in, and let's just put them in order. So we'll run all the functions, which would be that function first. We'll add the new road, the other road function, which is D, and we'll run the two Kerb return functions. We'll give it another one. So I'll run all these Kerb return functions. Okay, write that one away. Give it a, at the end, we'll give it a view refresh. So redraw all views, write that one, and then run. And so it should run all those four functions together. So in the 3D view now, you probably saw that shift across. We've now moved that, and that is actually a 3-centered curve. So what I'm going to do now is take a look at the one on the other side. So now that we've got that chain set up, it becomes very easy. So in here, if I wanted that as a 2-center curve, so I just go to horizontal into my compound, grab that, and do a 2-center curve this time. FX string, that's what we want. And the approach radius in this case, I could make, say, -15, and then we'll do a -30, and maybe a tangent length of 18 meters, so it works. If I hit set, okay, that nothing works because again it's lost its FX string. So let's go pick that string, and the offset of that one was -2.7. Set that, and the FX of this one out that way was -4.2 meters. So this should give us, you can see it's solved already, but now we're solving it back that way. Okay, again the vertical, if I go and take a look at the vertical, it's only partial vertical again. So under the vertical FX line, rather than make at vertex index 2, I'll make it 3, because we now have 3 vertices on that line. So vertex at the beginning, vertex in the middle, and vertex at the end. Set that up. So it's got vertical geometry for the whole length of the line. Run the chain now, which is the design chain. And so you should see in the 3D view, there you go, it's shifted out with the 2-center curve. So let's now take a look. If I turn on the tin back in here, tin super design. Again, it looks quite a reasonable grading through that particular the particular intersection. Now let's have a look at cul-de-sacs. Let's have a look at the cul-de-sac. Let's have a look at producing a cul-de-sac at the end of the road up here. So if I just turn off this, turn off my super design. Now got a bit of a string here. So cul-de-sacs again can be put in by manually by just putting a super alignment in, or else they can be put in via that same macro that I used before. So this one here on the roading toolbar, the Computator Kerb Return and Computate Creator. So in this one here, the secret is to just drop this area here and change it to a cul-de-sac. So it gives you a little diagram of a cul-de-sac, and in the diagram, what I'm going to do is, I know, of course, this road from before was 2.7 meters offset. So this is referring from there to there. 2.7 meters. Sign's not important. The macro sorts out the sign. 2.7. And I've got a 15 meter radius. So this refers to that radius on the way in. A 15 meter radius on the way out. And basically, in here, I can do it the way it is, and I'll just show you what happens. We'll create a few of these just to show you the differences, and you can offset it. This one here, yeah, 2.7. So the label style in here, again, I'll use the Kerb left-hand side. I'll call this RSK DO3 for this one. Model, might stick it in the alignment. Kerb's one again. Color green. Make sure I turn off the Create Apply Menu, because I'll apply it through the manager again. And then, yeah, basically that's it. I need to just select the center line and then hit process, and it's drawn me up a cul-de-sac. So how easy is that? Okay, and I can fool around with the dimensions of that cul-de-sac, or the parameters that you type in here. If I wanted an offset of 1, I'll just do that, offset of 1. It'll draw it and offset it 1 meter to that way, to the positive offset. If I wanted an offset of, say, -5. So it's doing the complicated geometry for you. It's now produced this one in here, okay, with an offset of 5. Okay. And what we normally do too is we don't stop our design string in the middle of the cul-de-sac. Normally we take our design string, or the centerline string, through to the end of the cul-de-sac. And I can see here that at the end I've got a radius of 9. So normally I make this here the other end of my cul-de-sac. I normally make that, or I think it's called projection of my cul-de-sac. Usually make that, yep, center projection -9. Or actually, I think it works with 9. So if I type 9 and hit process, that didn't work. It must be -9 that I need up here. Yeah, that's correct. Once I put -9, oh, I've still got the offset in there as well. So if I put a naught offset process, it's now brought it back and drawn this one here, so a more symmetrical type one. So let's go through, and I'll just delete a few of these ones that I was creating and keep that one. So it was 9 meters projected backwards, okay, 15 meters there, 15 meters there, 2.5, 2.5, and I've got that projected to the end. So that's all I need this one for. Okay, and what that simply does is it does a back-to-back curves in the horizontal, in the vertical. So if I took a look at the vertical, it's just back-to-back curves. Normally I wouldn't want that. Normally you try and tip your cul-de-sac one way or another. So this is the way I normally go about it, because this becomes very, very flat, this cul-de-sac. So normally at this stage I use what's called a road widening envelope. So I just grab that from, you can grab it from Design, Roads, More, and it's called road widening. Or you can grab it off the toolbar, road widening, off the road toolbar. I'm just going to call this function here WID, and I'll call it RS2 DO1. Okay, and what this does is it gives me, if you've never used this before, it gives you an envelope to design between. So I normally want a tin for my minimum and a tin for my maximum. My minimum crossfall, in this case I'm going to put it in -3% crossfall. My maximum envelope is going to be 3% crossfall. The beauty of this is it's a function, so I'm able to run it and then make changes to it. So just going to grab the reference string, just say I want it off that particular string, and then rather than do it for the whole length of the string, I'm just going to change my start chainage in here to maybe 210, just so I cover the end of the cul-de-sac. Okay, everything looks good. A section separation of 1, a maximum width of 15. That should cover the length out. And rather than do it just the left side of the line, I'll do it on both sides. So I'll now hit Process. And so I can see now that these sections automatically have covered the whole lot of my cul-de-sac. So if I turn on these two, the tin max and the tin min, I should get an envelope I can design between. So under here, I'll turn on those two particular tins. So the alignment to widen tin, and the alignment to widen max tin and widen min tin, and I'll add that. So what I'm attempting to do in this one is I'm going to take the horizontal or the vertical grade up to the maximum, the tin max, which is what I put in here as the maximum crossfall of 3%. I'm going to stick it to the tin max all the way around to where these lines cross, or close to where they cross, and then I'm going to use the -3% crossfall. So basically all this here will be at +3% crossfall from the center line, and on this side it'll be -3% crossfall. So what we'll end up with a cul-de-sac that sort of sheds water down to this in that direction down there. So this here, of course, it's a function, so it can be run at any stage. If you've got any changes to it, you want to change the envelopes, you can run that again. So I need now to open up this super alignment, the RSKDO3. Now if I look in there, from the command in 12D, it's set up the horizontal for me already. So if I do need to make changes to that horizontal, I can change projections, I can change the cul-de-sac radius or the widths, okay, or the left and right radiuses, which string it comes off. But the area I'm looking forward to changing is the vertical, okay. And then the vertical I mentioned, all it's doing is just it's linking on to the start grade here, the end grade here. It's putting in reverse curves between the two, as you can see by the free compound. What I'm going to do is just make use of that free compound. I'm going to do an insert, and I'm going to insert a special computator that is called a Fixed Point Computator. And this Fixed Point Computator, I'm going to say stick to this cyan tin up here that I've made through my function, one of the envelopes. So I don't want it to drape for the whole length of the tin. I'm going to change this to tin drape and give it 2 extents, so I can control the chainages of where I'm draping on that tin. So the tin I'm going to drape on this side is the widen max because I want to pull this up, okay, to the 3% crossfall. Then I'm going to change it to typed or fixed value chainages, and I'll do it between chainage 15 and the end chainage. I'll do a typed value again. It's looking in this particular case pretty close to maybe 29%. So basically what it's doing here is the fixed compound, because I said I wanted to start it as 15, it's putting in reverse curves till it gets to 15, chainage 15, and then from chainage 15 it's sticking on the top of that tin until it gets to chainage 29. Okay, then it's erroring out because it can't get back to this fixed grade or the fixed line. So what we have to do now is we have to either stick it on the minimum one here, or we eventually need to put in some free compound curve anyway. So let's go to point number 3 or element number 3, insert, and I'll insert a parabola free compound curves again, and maybe 50%. And what you'll find is that in this particular case, I really don't need to select the, I really don't need to have another fixed point computator in there to stick it to the tin. Look, it's close enough. It's very close, as you can see. Very close to sticking to that tin. If I wanted to manipulate the low point, I could probably make it a little bit closer by changing leading length on the curve, maybe to 60. Oh no, it's probably a bit much. It's going a bit deep there. 55. There's probably a better result at 50. I don't want to go too deep with it. That's pretty close to it anyway. So that gives you an idea of how we've graded that up to 3% crossfall, and then now minus 3% crossfall as we go through there. It's very close to that envelope. So finish that. I might just turn off the alignment widen min max. And now I need to apply the template around it. So if I go apply MTF manager and just use it by string, pick this. Okay, the left hand template again was curb left hand side, and I'll do a road tin, add it to my design view. Won't make a chain this time. Everything looks good there. So if I now hit create and update, it now should have, in my design view at the cul-de-sac, it should have now created, yep, which it has. It's created the sections and the strings around my cul-de-sac. So what I need to do firstly is I need to go and trim these ones back. So I'll go into my MTF file for the main road, and on the left hand side, rather than go to the end chainage here, I'm just going to go to, if I flip back to my alignment view, so we're looking at the left hand side, I'm going to go to the start of other string, and the string I'm going to start from is this one. I wouldn't use the I don't on these ones okay, string name must be unique. It must mean, that's what I sometimes get. There must be two strings in there called RSK DO3. So if that ever happens to you, you go to your string info table, you look up alignment curbs, and I can see in there I've got an RSK DO3 string. It's got a chainage and a length of 0, so obviously garbage. So that's a good way of, if you get that unique string, or string name must be unique, I can go and click on that. Because it's not on the screen, it has no length, I can just hit delete off here and that will remove that. So that's a good bit of debugging. If I set, that's now taken it. So I use the start and the end of this string. You can't use the lowest and highest drop change of this one, because who knows, you might pick up the wrong side of the cul-de-sac. So I know the string's been drawn in that direction, so I'm going to use a start. Okay, and I'll just copy that one down. So copy, Control C on the keyboard, Control V, and apply. That should sort out the left hand side, and the right hand side, again, exactly the same thing, except the end. So, oops, wrong one. This one here. So the end of other string, pick the string, it'll be the end of that string. Okay. We'll do a copy of that. Control C, Control V, apply, and away she goes. Now in the design view, we've got there's our cul-de-sac. If I look in the 3D view, of course I need to add that tin to the super tin. So I'll bring up the super design tin and I add to it the super tin, that extra tin, RSK DO3 update, and there it is there. Now I haven't got the center field out, so how do I get the center field out? Again, we use that snippet that I previously had. So I'll just do a save and finish on that one. So that's all okay. And edit data, pick here. Always make sure recalc's on. This time the right hand side, use that same snippet, and the snippet we're after is the insert in paint grade, and this time the approach string and the departure string are the same string. Approach string that way and the departure string back the other way. Now if I hit apply, there you go, got the center of my roundabout, center of my cul-de-sac. So basically, yeah, that's it for the cul-de-sac. So I can save and finish that and edit chain. And if I look at my design chain, I'll go into here, insert, and in here I would add the function RSK DO3 now, write that away and run that. And above this here, if I wanted to do it, I could also put in the resolving of my strings as well, my Kerb return strings if I wanted to. So just by insert and elements, resolve super alignment, and if I just pick this super alignment, okay, insert, same deal, element, execution, sorry, elements, resolve super alignment, pick this super alignment, insert, elements, resolve super alignment, pick this one as well. So write that one away. So now I've got the solving of the super alignments in there as well. So I can run that. So it just means that if you do change one of these particular super alignments now, that it's going to be resolved automatically for you. Okay, so that's it. Just wondering if there's any questions.
Thanks for that, Matt. Now I'll just take one of these questions live, I think. Dave in South Australia has asked, how do you handle Kerb returns that are brought in from CAD?
Thank you very much for your question, David. Just in regards to Kerb returns that are brought in from CAD, I tend to, if you bring them in, you can bring in Kerb returns and use strings convert, and that'll convert them over to IP method. If you could use utilities A to G convert, you can convert to super alignments, and you can actually choose there whether you convert them to elements or IPs. But unfortunately, all we can really do in these when we do the conversions is the first element. If you've got more than one element in your Kerb return, we'll just create that as a fixed element, the first one, and then we'll use floating elements after that. So it's really not a lot of use to you doing the conversion. Oftentimes, as you see, it's not that long. It doesn't take that long, but you can go through and recreate your Kerb returns in 12D. Then you know the geometry of them is 100% correct. Everyone, I'm sure, has tried bringing them over from CAD, and you find that sometimes the tangents, you do tangent to tangent curves, they don't exactly match. It's a lot easier, I think, just to trace them off in 12D and use them from there. So yeah, hopefully that answers that question. Yeah, so normally I just trace them off, and you get the added benefit then of you're able to change them really easily, and then you can, if you do need to take them back into CAD, take them from 12D back into CAD. Just do a write out to a DWG file and write them out to 2D, and then the horizontal geometry will get out. Okay. No more questions. Yeah, we're running out of time. Thank you very much for your attendance today, and yeah, good luck with your Kerb returns and good luck with your cul-de-sacs. Thank you.
Thank you, Matt, and thanks to our audience for your questions. Sorry to those whose questions we couldn't get to live today. We'll answer you by email soon. We've got some great training courses coming up in Brisbane, Melbourne, Perth, Hobart and more. The handout available on this webinar outlines what's in some of these, and you can register through the training page of our website or contact us by email for more information. The recording of today's webinar will be available in coming days through our website and our YouTube channel. We'll keep you posted on upcoming webinars through email and social media if you're subscribed, and if you need to contact us in the meantime, our details are on the screen now. That concludes our presentation for today. Thank you for attending, and we hope to see you at future webinars.